Hi, this is Mr. Rutherford. In this problem we will look at a real-world example. Nature. Write a coordinate proof to prove that this tree is shaped like an isosceles triangle. The tree is 8 feet high and 2.6 feet wide. Notice our tree is placed in an XY coordinate plane. We're told that the tree is 8 feet high and 2.6 feet wide. Now, we need to make a shape of a triangle here, so I'm going to find 3 points. I'm going to place the first point here at the origin. I'll label this Q. Next, we'll move to the right and place a point to the right of the tree, and we'll label this as R. Then finally we have one more point, which is the top of the tree, and we'll label this S. Now we need to find the coordinates of these 3 vertices. But first let's connect these with a straight line to show that we have a triangle. So we know that the point Q is at the origin, so this will be 0, 0. Next, let's find point R. We're told that the tree is 2.6 feet wide, so this means our x-coordinate will be 2.6, and we have a y-coordinate of 0, because our point R lies on the x-axis. Now, in order to find S, we're told that this tree is 8 feet high, so this means that the y-coordinate will be 8. And to find the x-coordinate, we need to cut the tree, or the width, in half. So we're told that the width is 2.6. If we multiply this by 1/2, we get 1.3. So this means the x-coordinate of our S will be 1.3. Now, in order to classify this as an isosceles triangle, we need to use the distance formula and find the length of each one of these sides. Now, we know that the length of QR is going to be equal to 2.6. But in order to find out whether or not this is an isosceles triangle, QS and RS need to be congruent or equal in length. So first, let's find QS. We're going to use the distance formula. Remember, the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we need to identify our x1 and y1. So we'll label for point Q, 0 is x1, and our other 0 will be y1. And then for the point S, 1.3 will be x2, and 8 will be y2. So let's substitute these values into our distance formula. So we'll have the square root of 1.3 minus 0 squared plus 8 minus 0 squared. So we'll simplify this, and we'll have 1.3 squared plus 8 squared. When we square 1.3, we get 1.69 plus 8 squared, which is 64. So here we have that QS is equal to the square root of 65.69. So now we need to find the length of our other side, which is RS, or SR, to find out if it's equal to the length of QS. So RS will be equal to, we need to again label our x1, y1, x2, and y2. So we're erasing here what we had before. So let's just fix this here. So now, in order to label these, notice again we're finding SR, so let's go ahead and label our R as the X1, Y1, and our S will be the X2 and Y2. So now let's substitute these values into the distance formula. So we'll have the square root of 1.3 minus 2.6 squared plus 8 minus 0 squared. So here we'll have 1.3 minus 2.6 is negative 1.3 squared plus 8 minus 0 is 8, so we have 8 squared. Now negative 1.3 squared will be positive 1.69 plus 8 squared, which is 64. So this again is equal to the square root of 65.69. So we can say then that segment or side QS is congruent or equal to side RS. Therefore, we can say that this triangle QRS is an isosceles triangle.